example 7, we're going to look at another real world problem. However, this one's just a slightly more complicated. So here we go. A hot air balloon that is moving over a neighborhood has an angle of depression of 28 degrees to one house and an angle of depression of 52 degrees to a second house. If the height of the balloon is 650 feet, estimate the distance between the two houses. So basically we got a balloon and it's going that way, and there's a house here and a house here, and it has an angle of depression like this and an angle of depression like this, and we want to find this distance. A much prettier picture of that is this. And they even draw all the triangles for us, which is really nice. So whenever I have problems like this, I typically like to physically write this down. So I physically write down, what do we want? So what we want to know is the y, which is the distance between the houses. So we want this distance right here. So what we want to do is take this gross looking thing and just create some more simplified versions of it. So we can see we have a triangle here, and we can see we have a big triangle here. So what I like to do then is just right below it, I'm going to draw my little triangle, which looks like this. And that is this inside triangle, so the bottom of it is x. My angle is 52 degrees, and my height is 650 feet. That's just from the problem. Now I'm going to draw a second triangle in. And this triangle, the height's the same, 650. But this time, the bottom of the triangle is this whole piece. So it's x, this distance x, plus this distance y. So this is x plus y. And I have an angle here of 28 degrees. So my goal, again, is to solve y. So I'm going to put over here, I'll put y equals, and then blank, that's my goal. So if I can find x, I'll be all good. I just need to find x first. Well, I know that these are right triangles, so I get to use my sine, cosine, and tangent. So from this triangle right here, I have tangent of 52 degrees is equal to opposite, so 650, divided by the adjacent, which is x. So I can actually solve for x right now. So I get x times tangent of 52 is equal to 650. And then I'm going to divide both sides by tangent of 52. And that's just a number, so I'm going to use that later. Now what we're going to do is we're going to set up our second triangle in the same exact way. So this time, over here, I have tangent of 28 degrees is equal to opposite, 650, divided by the adjacent, x plus y. Now my goal is to get y by itself. So step 1, get it out of the denominator. I'm going to multiply both sides by x plus y. That's going to make this reduce off, and I'm going to get x plus y times tangent of 28 degrees is equal to 650. The next step is then to divide both sides by tangent of 28 degrees. So this reduces off, and I get x plus y is equal to 650 divided by tangent of 28. Now, since I want y by itself, again, my goal was to get this by itself, I'm going to subtract x from both sides. So I get y is equal to 650 divided by tangent of 28 degrees minus x. Well, remember, I actually did find x. It's right here. So I'm going to take this value and put it in there. So I get y is equal to 650 divided by tangent of 28 degrees minus 650 divided by tangent of 52 degrees. And all I have to do now is just put it in the calculator. So here we go. 650 divided by tangent of 28 minus 650 divided by tangent of 52, and I push enter. And I get 714.63. And then I'm going to go ahead and round that to the nearest tenth. So y is about 714.6 feet. Again, this is the distance between the houses. Okay, here we go. Let's do another one. But this time I want you guys to do on your own. So we have an angle of elevation from a car to the top of an apartment building is 48 degrees. If the angle of elevation from another car that is 22 feet directly in front of the first car is 64 degrees, how tall is the building? So here's a picture of it, so you can see it a little better. And then now I'm going to let you guys to try to do this one on your own. Alright, so let's first break this down. I'm going to show you where the two triangles are. I have one triangle right here. And I have my second triangle on the inside right here. And I'm going to use that information in order to find this height right here. So for the sake of our problem, I'm going to go ahead and call this x. And so now we got to draw our triangles. So below this, I draw my triangle again, like this. And this I don't know, so I called it x. And the distance here is 22 plus some unknown value I'm going to call y. So this is y plus 22. And the angle right here is 48 degrees. Now I'm going to draw my second triangle. And the angle here is 64 degrees. This is y. And this is x. So now I can set up two trig equations to represent these triangles. So I get tangent of 48 degrees is equal to opposite x divided by adjacent y plus 22. And then here I get tangent of 64 is equal to opposite, so x, divided by y. There's a couple different ways to solve this problem, but I'm just going to go ahead and solve it one way. If you had a different way, that's just fine. So I'm going to get both equations solved for x. So I'm going to multiply this one by y plus 22. And I get y plus 22 times tangent of 48 is equal to x. And over here, I'm going to do the same thing. So I multiply both sides by y, and I get y times tangent of 64 degrees is equal to x. So now what I'm going to do is on this side, I'm going to divide both sides by tangent of 48. So I get y plus 22 is equal to x divided by tangent of 48. And then I'm going to subtract 22 from both sides. So I get y is equal to x divided by tangent of 48 minus 22. So I want to solve for x, so I actually need to get this y out of here. I'm going to do that by using my other equation. So I'm going to divide both sides by tangent of 64. And so I get y is equal to x divided by tangent of 64. And I'm going to put this piece of information in there. So now I have x divided by tangent of 64 is equal to x divided by tangent of 48 minus 22. So I want all my x's on one side. So I go x divided by tangent of 64 minus x divided by tangent of 48. This equals negative 22. So notice that I have an x in both of these numerators. So I'm going to factor out the x, and I get 1 over tangent of 64 minus 1 over tangent of 48, and that equals negative 22. So from here, this whole thing is one term. So I'm actually going to divide everything by it. I know that seems really gross, but that's okay, because we're just going to put it in a calculator anyways. So I'm going to divide that to both sides. So I get x is equal to negative 22 divided by 1 over tangent of 64 minus 1 over tangent of 48. And now all I have to do is put this into a calculator and I'll be good to go. So I'm actually going to use a little function on our calculator, which is the fraction button. It makes the fraction for me, which helps me not make a mistake. So it's negative 22 divided by, I need another fraction, 1 over tangent of 64 minus 1 divided by tangent of 48. And I push enter. So I get 53.31. So x is about 53.31. And I'm going to round that to the nearest tenth, and I get x is about 53.3 feet. So that means the height of the building is about 53.3 feet.